All right, this is Math 209 Week 3. We're doing section 7.7, which is really just more solving proportions, although this time we're going to do it in a different style called direct variation, or we're going to do inverse variation. So what the heck does directly proportional mean? Okay, so the idea is when it says suppose y is directly proportional to x. So what that means is you can make an xy table, and it says, and that y equals 56 when x equals 7. So what that means is when y is equal to 56, x is equal to 7. All right? So now we're supposed to find the constant of proportionality. So what I'm going to do is I'm going to take a minute and I'm going to delete that. And I'm going to delete this guy as well, because I'm going to change the table. Instead of an xy table, I'm going to do what's commonly called an xky table. So it's going to be xky. All right, and it's basically, I'm just adding a little bit of scaffolding to help you a little bit. So it says when y is 56 when x is 7. So y is 56 when x is 7. So now what we're supposed to do is we're supposed to say, we know that the formula is x times k equals y. All right, so if we're saying x times k equals y, and we have 7 times something is equal to 56. So what does that k equal? In this case, k is equal to 8. Now, how could we have figured that out if we didn't know it off the top of our heads? We would have done 56 divided by 7, and that would have given us our answer. So it turns out y divided by x equals k. So y divided by x is equal to k. Now that's an important little formula that you're going to need to know. So write it down, and we're going to use it a lot. So now down here, here, look at this. They put y is equal to kx, but look what I did. I called it x times k is equal to y. So they have the same formula as I do. I just like my order a little bit better, but it's the same formula. Now, this question says, use this formula, that's my table, to find y when x is 9. So now they're saying, so if x is 9, what is y equal to? Well, we know that k is still 8. So 9 times 8 equals 72. So that means y is equal to 72. So again, we're going to be doing a proportional table here, a proportion table. And our table is x, it's 3 columns. It's x times k equals y. All right. And so we are told that y is 3 and x is 2. So y is 3 and x is 2. So we're supposed to figure out if x is 2 and y is 3, then what the heck is k equal to? Well, the way you find k is you're going to divide 3 divided by 2. Well, 3 divided by 2 is not a whole number, so we're just going to leave it as a fraction, 3 over 2. So that means k is equal to 3 over 2, and that's why we have the answer right there. The next part says, well, find y when x is equal to 6. So if x is equal to 6, and it's going to, what is y? Right here, what is y? Well, first off, what's k? Well, k is still 3 halves, because once you've discovered what k is for a table, k will always be 3, in this case, 3 halves, the entire problem, this entire table, until we switch to a new problem. And that's why k is called the constant of proportionality, because once you found it, it doesn't change until you moved on to a new problem. So now that we know x is 6, k is 3/2, now we have to figure out what y is. Well, that's just a multiplication problem. So that's going to be 6 over 1 times 3 over 2. So that's 18 over 2, which is equal to 9. So y is equal to 9. All right, so we have, again, we're being told that we have a direct proportion. And so that means we can use that x times k equals y table. So x times k is equal to y. And we are told that, let's see, y is negative 63 when x is 7. So you've got negative 63 when x is 7. So that means 7 times something has to equal negative 63. So what does that mean? Well, we're going to do negative 63 divided by 7, and that gives us k. And so that means k is equal to negative 9, and k is allowed to be negative. So now that we know that k is equal to negative 9, it's going to be negative 9 on every single row for the rest of this problem. All right, so now we're told that y is equal to 6. Well, if x, we're told that x is equal to 6. So that means 6 times k, or 6 times negative 9, is going to give us our value for y, and we don't need that anymore. So we know that 6 times negative 9 is negative 54. So y is equal to negative 54. Reading is really careful, is important, because I actually missed this the first time I did this problem. Inversely proportional. Now we have a new rule. All right, the new rule for inversely proportional. Okay, so the new table. So you still have a 3-column table, but when you're told they're inversely proportional, now you need to know that x times y is equal to k. It's a little confusing because you have the same stinking letters, but now it's in a different configuration. So now it's x times y is equal to k. So we are told, suppose that y is inversely proportional to x, and that y is 12 when x is 2. So y is 12 when x is 2. So now we're supposed to figure out what k is. Well, we're told that x times y is equal to k. So that means 2 times 12 is equal to, and so what is k? Well, k is going to be 24. And there you go. And so that's how we got 24 right there. So now it says, find y when x is 6. Well, if we know that x is 6, we're supposed to figure out what the heck y is equal to. Now, we have to remember that k is 24. So basically, this is saying 6 times something equals 24. So all we have to do is a little bit of division. 24 divided by 6, that's going to give us y. So we know that y is equal to 4. Again, we've got an inverse proportional story here. So our table, remember, our 3-column table, it's x times y is equal to k. And we are told that y is 100 when x is 1/5. So now all we have to do is a little bit of multiplication. So all we have to do is 1/5 times 100 over 1, and we can do a little bit of simplifying. So that's equal to 20. So we know that k is equal to 20. So k is equal to 20. So now the second question, there you go. So the second question, you'll notice, by the way, I use a different formula than they do. It's the same, it's the same formula, just in a different configuration. So I like mine better, quite frankly. So that's why I stick with mine. You're welcome to use their formula if you want. But it says, use this number to find y when x is equal to 4. So we know that x is equal to 4. We're supposed to figure out what the heck y is, but we know that k is 20, right? K is still 20, because once you've figured out what k is, it's always going to be that same value because it is the constant of proportionality. Well, if x is 4, we don't know what y is, but k is 20, well, that means y is going to be 20 divided by 4, which is 5. So y is equal to 5. And again, we have an inverse proportional relationship here, so we are going to use the 3-column table, and it's going to be x times y is equal to k. And we are told that y is 9/2 when x is 18. So y is 9/2 when x is 18. So we know that 18 times 9/2 is going to give us our value for k. So we need to do 18 times 9/2. Now notice I put 18 over 1 because that's how you multiply, right? And so before I go multiplying straight across, I'm going to do a little bit of reducing. I see that both 18 and 2 are divisible by 2. So 18 divided by 2 is 9, and 2 divided by 2 is 1. And I made the problem a little simpler. Now I have 9 times 9, which is 81. And then I have 1 times 1, which is 1. So our answer is 81. So what is our k? K is 81. And that's exactly what I had over here. So now that we know that k is 81, k is always going to be 81. In fact, k is always going to be 81. So now this says find y when x is 9. So if x is 9, we're supposed to figure out what y is, and that's really easy. So basically that's saying 9 times something equals 81. So that means y is equal to, well, whatever 81 divided by 9 is. Oh, it's 9. So y is equal to 9. And that wraps up this video.